Hey, good morning. So in this video, I'm going to go over questions 15 and 16 off the Quadratics review. And these questions are going to deal more with the application type problems involving quadratics. In question 15, it talks about Luis kicks a soccer ball and the graph shows the height of the ball over time, and we have our picture. Now when you get your test, you won't have the picture. You're going to have to use your calculator to get the picture. But here when it says the starting height of the ball is blank feet, that starting is referencing the y-intercept. So where it crosses the y-axis, this is my y-axis, and the graph crosses right at the origin, right at 0. So it starts off on the ground, which would be 0 feet. The ball reaches a maximum height of approximately, so approximately is telling us it's okay if we round a little bit, which we're gonna have to do because I don't have the actual equation representing this graph. I just have the graph itself, okay? So the maximum height is our y values. So I wanna know what is the y value of that vertex. And so if I look here and I kind of go over, I'm gonna estimate it to be about maybe 38 or 39 feet. So I'm gonna go ahead and go with 39 feet. After seconds, this is gonna be the x value. This is how long did it take. And I see that is gonna be 1.5 seconds, so 1.5 seconds. From there, the next question is telling us the ball returns to the ground after blank seconds. So here it goes up, it's still in the air, still in the air, and then right here at the 3 seconds is when it returns to the ground. And then the last part is asking us to identify a reasonable domain and range. Okay, so usually when we're talking about domain and range, that's not involving a real world situation. Domain, because quadratics go on forever and ever, domain would be all real numbers. However, since in this particular problem we have words associated with the problem, all real numbers would not be valid because that means we have negative time and negative feet. So for our domain and range, I want to stick to just what's visible on the graph. Domain, x values, which go left to right. From the left, I encounter my first x value at 0, and it goes all the way up to that 3. So my domain is going to be all of those x values, including those decimals from 0 to 3. So when I write it, I write my x in the middle with my less than inequality symbols, less than or equal to on each side, 0 to 3. And so this is telling me x is greater than or equal to 0, but less than or equal to 3. And so any number that meets that criteria would be part of the domain. Range are the y values. So I'm going to go ahead and set it up. Y values, that's vertical, goes from the bottom to the top. So same thing from the bottom. I first encounter the graph at that value of 0, and it goes all the way up to what we said earlier at that max of 39. So my y is greater than or equal to 0, but less than or equal to 39. Okay. On the next part, question 16 is talking about athletic Adam threw a ball straight up with an upward speed of 40 feet per second. His hand was 8 feet above the ground when he released the ball. It says write a function that models the path of the ball, and then it's giving us this is our formula, and it's already been filled in. So that when it says write a function, it's already taken care for us. That equation, especially when you get your test tomorrow, the first thing you want to do is going to be go ahead and type it in. So you can see here, I've already gone and typed it in. We get our parabola, okay? And I can see it's very narrow. The first question is asking how long was the ball in the air? So that's asking when did it come back and reach the ground? That is asking for the rocks, okay? That is the root, the 0, the x-intercept, or the solution. Using my calculator, if I want to get that, I can go to menu 5.1 to trace. When you go to trace, menu 5.1, when you go to trace, it automatically should default at the y-intercept, and then I'm just going to arrow over to the right because I want to get that value of the x-intercept. Notice here, as I'm arrowing over, I get my max. I'm going to go ahead and write that down. That max is representing my vertex. And I'm just going to do that to kind of help save time because it might be needed later on. Okay? So I'm going to go ahead and continue to arrow on over. I want to see when does it come back and hit the ground. And I see I have my 0. And it's giving me an approximate to decimal, and that's okay, 2.9 or 2.69 seconds. Okay. Then it says what was the maximum height. So there's where I need my vertex because this is my time and the y value is my height. So since I already found it, I can go ahead and write it here. It reached a maximum height of 33 feet. Okay. If you wanted to verify on your calculator, you could go to menu, analyze, which is option 6, analyze again, option 8, and then we go to option 2 for the vertex. And when I click on the graph, I get that same value. 5/4 is the same as 1.25. Okay. How long did it take? This is our time, and that's 1.25 seconds. It says, after it reached maximum height, how long did it take to drop to Earth? So once we're at our maximum height at 1.25 seconds, how long from that maximum height did it take to come back down? So in order for me to find that, I want to take its total time in the air, which is 2.69, and subtract how long it took to get to that highest point, which is our vertex, x value of 1.25. Okay, and you can subtract either here in your calculator, whichever makes you happy. And it's going to be 1.44 seconds. It took just under 1.5 seconds for it, once it's reached that vertex, to come back down to the ground. Domain is the x value, so I can use my graph here or the information I've already gathered. Domain, those are the x values, goes left to right. Remember, domain x values is our time. I cannot have negative time. So I'm going to start time at 0, and it's going to keep on going until where that ball came back down to the ground. And that's going to be the x-intercept, which we found when it said how long was the ball in the air. That was our x-intercept. So that would be my second, or the ending of my domain. The range, y values from the bottom to the top. Once again, we can't include those negatives. So I'm going to have my y with my less than or equal to symbols before and after. It starts at the 0, and it went all the way up to that maximum height, which was 33 feet. All right, remember you could do this. If I wanted to know, okay, well, how long, what was the height at exactly 1 second? I could either do Control T and look at my table, and I can see at 1 second it was at 32 feet, so it was almost at its maximum height, which makes sense because a quarter of a second later, it was at its maximum height. Or if I'm tracing, menu 5.1, I can either arrow over, or if that's taking too long, I can just go ahead and press the 1, enter, and it will give me that same value. So you might need to do that here on your test. And then, of course, you can continue to arrow over whatever you need to get the answers that are being asked. Good luck.